Hey everybody, it is Mr. Zabo. We are starting here on Chapter 5. Hopefully everything went well in Chapter 4. Chapter 5 is all going to be about our equations of lines still, but we're going to really start looking at the graphs of them. We're going to start looking and focusing on lines in a great bit of detail. So the first topic, the first term that we're going to learn is slope. Slope is the ratio that compares the vertical change to the horizontal change in your graph. So the vertical meaning the up and down, the horizontal meaning the left and right. We've done this a lot already, we just didn't call it slope, we didn't call it rate of change. We just said, hey, what's happening here? Describe it. So for example, we might have looked at a graph on a coordinate plane of something like this and said, hey, this car's about to climb uphill. And it's going to be a 4-meter long hill that climbs 3 meters. When we are setting up this comparison, we want to talk about the ratio. Now, good news and bad news. Ratios we've done. That's the good news. Bad news is, remember, those are fractions. But don't be afraid of that. We've done them. We were really, really good at them, and you guys are going to be great at them again here. So, as I go to start describing the slope here, the vertical change of this slope is 3 meters, and since it's going up, we would consider that a positive 3 meters. Then the horizontal change, how far are we going from left to right? Again, we're going to the right, it's 4 meters, that's a positive 4. Since the vertical change is a positive 3 meters, the horizontal change is a positive 4 meters, we would state that the slope of this situation, let's get that set up there, is 3 over 4. The ratio of the vertical change to the horizontal change. And it's positive because it's going up. Slope is like a sentence. We will always read it from left to right. Let me repeat that. We are going to read slope from left to right. So I would not read this sentence as hill a climb to about is car this. That wouldn't make sense in the way that the English language works. I wouldn't read this slope from right to left. That wouldn't make sense in the way mathematics works. Taking a quick look at the second example, because it is a little bit different. In this case, the car is descending down the hill. Again, we read this left to right. This time the car is descending the hill. Not hill the descending, is car the time this. And if I'm comparing my vertical change, I'm going down 3 centimeters. To my horizontal change, I am going to the right 4 centimeters. I am comparing negative 3 centimeters as a ratio with positive 4 centimeters. That makes my slope negative 3/4. So a quick summary of this page. When we are dealing with slope, here's what we're looking at. It kind of fits on this page here a little bit. Vertical change over horizontal change, left to right. If we're going up, it's positive. If it's going down, it's negative. Alright, now the last part of this video, putting that into a formula, into an actual equation or an idea here. So we've already talked about slope being vertical change over horizontal change. When we're looking at in a coordinate plane, that's the change in your y coordinates divided by the change in your x coordinates. When we're dealing with change in coordinates, that's subtraction. I am going to subtract my y coordinates, divide by the difference, or subtract my x coordinates. We use this triangle here to represent the change in, that's the word delta, but we just say change in y over change in x, or delta y over delta x. Typically you're going to hear us speaking change in y over change in x. Okay. The way that we would write that is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What those represent is we would have 2 ordered pairs, an x and a y, an x and a y, an x1, y1, and an x2, y2. What's most important about that is your ordered pairs are lined up vertically. My xy and my xy. Which order that is doesn't matter as long as it's the same ordered pair is lined up vertically. So let's take a look at that down here. They're interchangeable terms, slope and rate of change. As we see up here, rate of change and slope. Okay? And they're often used in algebra without context to the problem. Okay? We've been talking a lot about describe the context, but we have no context in this graph. So this example below, we'd want to find the slope or the rate of change. Start on the left. We read from left to right. I'm going to go through my line left to right, and I see the first ordered pair I have is here. The second ordered pair I have is here. I want to read my vertical change divided by my horizontal change. So I can just count that out. My vertical change goes from 5 down to 4 down to 3. That is a vertical change. I went down of down 2. My horizontal change goes from 0 to 1 to 2 to 3. That is a horizontal change of 3. So I would say that the slope of this segment is -2 over 3. And real quick, what if I hadn't chosen this point? What if I chose this point instead? Well, I want us to see that we have 1, 2, -2, 1, 2, 3, a +3. It's the same slope. And the same idea. What if I went from here straight to here? Well, that would have been a 1, 2, 3, 4, a -4 change vertically, and a 1, 2, 3, 4, 5, 6 change horizontally. But what happens with -4 divided by 6? That's right, it simplifies to -2/3. So your vertical change and horizontal change should always be a fraction that is simplified. And this goes right to the heart of what we've been talking about all year. Write your fractions as simplified fractions. Don't round decimals. This is what we've been building up towards. And then one final look at a problem like this. What if we had gone this way first? Well, still, that's a horizontal change of +3 and a vertical change of -2. You still, doesn't mean you put the 3 in your numerator. The 3 is still your horizontal change. That goes in your denominator. Okay? So that's a negative slope because my line is going down from left to right. If we look at the last example here, I only have 2 points on the graph that I can absolutely be positive about, and that's these 2 points. So if I check my vertical change, it's up 1, up 2, up 3, and then 1, 2, 3, 4, 5, 6 to the right. My slope is 3 over 6. Always simplify slope. That's 1/2. If we had gone the other way first, gone right 1, 2, 3, 4, 5, 6, that's still a +6, and then 1, 2, +3 up, it's still 3 over 6, which is 1 over 2. That means if I went up 1, right 2, guess what? I would have been on the line still. Up 1, right 2, I would have been on the line still. That's the key. That is exactly what slope is telling us, and we're going to spend a lot of time in Chapter 5 on this idea.